Hello, I will now show you the pacemaker model in autofocus and how autofocus works, its requirements, implementation, architecture implementation, and so on. And the first thing to show is where I started. It was with the glossary, where I first collected all the things that are connected to the heart, like the sinoatrial node. And I wrote what it is and what it does and its abbreviations, its synonyms. I also added a nice picture so everybody can see what it is, where it is located. And then, after writing the glossary, I started implementing the requirements for the pacemaker. And one of the first requirements was this one, the system requirements bradycardia operating modes, which was copied from the Boston Scientific System specification for the pacemaker, which was released for the pacemaker challenge. And it said that all these operating modes should be programmable. And here in the blue things, these are links to the glossary. So if you put your mouse over them, you get a short explanation about what it is and what they do. And the modes were implemented as use cases. Here you see the AOO mode. This is one of the easiest modes for the pacemaker. And I wrote which are the inputs for this mode, which parameters should be set, and what it can do. So it's only pacing, it doesn't sense anything from the heart, it doesn't respond to the heart sensing. And I added the information where I got this from, and also the scope in which component it will be implemented, and which other requirement it refines. And to every use case, you can add scenarios, MSC scenarios, which describe which messages are sent from the pulse generator to the part of the heart. Like in this mode, it sends a pace signal to the atrium every heart cycle. And what you also can do is, for requirements, you can add a functional specification. Like in this requirement, which describes the minimal pacing frequency. That means that the pacemaker should maintain a specific heart rate so that the patient doesn't die. And you can add a very easy and simple function of a pacemaker, which just gets as input this rate and as output is a pace. And then you have a little state automaton which just waits and then paces if it's high enough, if it reaches the rate, so that you have sufficient paces. And after implementing the requirements, I started implementing the architecture. Here you see the pacemaker component, it's more a pulse generator component. And you get all those parameters which the physician puts in when it is implanted into the patient, and the mode in which it should operate, and pacemaker can connect it to the heart and get sensors from the atrium and the ventricle, and it also can pace those two. And here are the outputs. And then you can connect the requirements to the components. Like here I connected. Here you can find the connection between the requirement or the use case and the component. And you just press on it and come back where you saw it before in the requirements. And then in this pacemaker component, inside you find a mode automaton, where you switch the mode once in which the pacemaker should operate, for example the mode AAI. And then inside you find a new component which is just doing this behavior and nothing else. And here you see the input parameters and the output to the atrium. It doesn't need an output to the ventricle because it's only pacing in the atrium. And inside this you find a state automaton which is modeling the behavior of this mode. Yeah, and that's it about the architecture. And after you build this architecture, you can also build kind of a model of the hardware of the thing, and you get the component where, like, the processor on which it should run and its inputs and outputs. And then you can build a deployment where you can map the software components, this pacemaker, to these hardware components, as you see it here. And then you can also map the inputs and outputs from the software component to the hardware component, as you see it here. And after you did all these things together, you can just press on Run Deployment Generator, select any directory where you want your code, C code, to, like generation, press OK, and then you have the C code. And like, that's it. It's a pretty easy way of building all the requirements into a model and then into C code to run it on hardware.